Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Moore's Honors Algebra Geometry class. Sorry. Um, Today we're going to continue with area, guys, and we're going to talk about parallelograms and triangles. Still pretty basic, but remember you have to, in order to really master this, you have to understand how the diagonals work, okay? Remember that diagonals of parallelogram bisect each other, but they're not congruent. So be careful with that. Rectangles, they bisect each other and they are congruent, but parallelograms, they are just bisectors of each other. And the formula for a parallelogram is identical to the area of a rectangle. It's base times height or length times width. They will, for the most part, usually give you the height. Sometimes they will not, though. Sometimes you have to drop down the height and use the trig ratios in order to find the height. If you remember the trig ratios as SOHCAHTOA, sine, cosine, and tangent, or if you're lucky, you could use the 30, 60, 90 triangles or 45, 45, 90 triangles to be able to find the height. So everything, like I've been repeating, I know, like a broken record, it's going to be building up here. So you have to remember those things. The area of a triangle, quite simple, is base times height divided by 2. I know a lot of times people say, oh, isn't it 1/2 times base times height? Yeah, it's the same thing. Base times height divided by 2. Now, why do I have 3 triangles? Because they can give you the height in different formats. If I give you a triangle like this, let's say, for example, whether it's isosceles or not, I can drop down an altitude right down the middle. Sometimes I give you a perfect, beautiful right angle. A right triangle. Please be cognizant of the fact that the legs make up the height and the length, or the base and the height. The hypotenuse is never the base or the height, okay? It's never the base or the height. Please be cognizant of that. And then sometimes I could give you a scalene triangle where none of the sides are equal. I don't have a height inside of the triangle because of the slant, so I create a height outside of the triangle. Okay? So it's the same formula for all 3 ways of expressing the triangle. So parallelogram area, base times height or length times width, and the area of a triangle, base times height divided by 2, or length times width divided by 2. But very rarely do you see length and width for triangles, because triangle sits on a base. Okay? Pretty simple. Let's move on. So example 1. Find the area of each triangle. Okay. Pretty simple. Area equals base times height divided by 2. It's not that bad. Do yourself a favor. If you can cross reduce or reduce straight off the bat, do it. 10 divided by 2 is 5. 5 times 15 is 75. And please remember that it is 75 centimeters squared. Please. Always remember that when we're dealing with area, square units. Again, just in case you forgot, remember what area means, guys. It's not just a silly formula. Area means, bless you, how many square units can I fit inside of this figure? So in this particular figure, I can fit literally 75 squares that are 1 centimeter by 1 centimeter. Let's just say that this is 1 centimeter, which it's not, but let's just pretend. This is a square of 1 centimeter by 1 centimeter. So that means I can fit 75 1 centimeter by 1 centimeter squares inside of this area, inside of this figure. That's what area means. Always remember the value of understanding the definition. Number 2. Okay. Base times height divided by 2. Not that bad. Area equals base times height divided by 2. Sometimes people ask me, Mr. Morrow, what about this right here? Doesn't that account for the base? Shouldn't there be an X there? No. No, there should not. The base is going to be delineated by the solid part of the triangle. Okay? And again, here I would reduce. So giving me 28 millimeters squared. Again, what does that mean? That means that there are 28 1 millimeter by 1 millimeter squares inside of this triangle. Please, please really try to understand what area is. It's the number of square units inside of a triangle. Pretty simple, right? Okay. How about this bad boy? Find the base of a triangle with altitude 15 and an area of 60 units squared. Well, in this case, we're just reversing it. We know how to do this. Area equals base times height divided by 2. Fill in what they've given you, gentlemen, and find what they're looking for. You're looking for the altitude. You're looking for the height. You know that the area is 60, which equals base of x. And I'm sorry, you're not looking for the altitude. You have an altitude. You're looking for the base. Read, Mr. Morrow. Pay attention. So x times height, or altitude of 15, divided by 2. How do I solve this, gentlemen? Absolutely. Multiply everything by 2. So that gives you 120 plus 15x divided by 15. And x will equal 8 on the money. 8 units. Now, sometimes people will put 8 units squared there, and that will be inaccurate. We're looking for a base. Base and length are linear. That means it's just 1 unit. It's just feet or inches or miles or millimeters. Area is the unit squared. Please be cognizant of that. Pretty simple, right? All right. Find the area of a parallelogram whose sides are 14 and 6 and whose acute angle is 60. Okay, here we go. This is the one that I was talking about. Very good, my brother. You're going to have to drop an altitude here, guys. Okay? You're going to have to... Oh, sorry. You're going to have to drop an altitude here. Let me just make this a little bit larger. Okay? You're going to have to drop an altitude. So drop an altitude. Okay. The 6 represents what part of this triangle that I just created? The hypotenuse. This angle here is the 30, isn't it? So what's the small side of this triangle? What is the small side across the 30? What is the small side across the 30? 3. Because the hypotenuse is twice the small side. Guys, again, you have to remember your 30, 60, 90 triangle. When I teach these things and I tell you things like, guys, you have to know this, I am not paying you lip service. I am telling you the truth. I am not trying to scare you. I am trying to prepare you. So for those of you who don't remember this, I suggest strongly that you rewatch those videos. So if that's the small side, what is my altitude here? The side across the 60? 3 square root of 3. So now, there's a parallelogram. So area equals base times height. And area would equal 42 square root of 3. Does that make sense, gentlemen? I'm going to take that as a yes. Okay, you have to know this, guys. You have to. You have to. Now, just for giggles, if I gave you something similar, and I said that this was 50, that's not a special right triangle, is it? Is it? And let's say that I told you this was 8, okay? And I want to find, let's say I wanted to find the height of this, and I told you that the whole entire base was, let's say, 10. In this case, guys, we're going to have to use trig, SOHCAHTOA, sine, cosine, and tangent. In this particular case, this is an angle of 50. Across the 50 is my opposite. And then the 8 is the hypotenuse. So who uses in SOHCAHTOA the opposite in the hypotenuse? The sine. So this would be sine of 50 equals opposite over hypotenuse. So x would equal 8 times the sine of 50, which I cannot do that in my head because the sine of 50 is not a known angle. So you go sine of 50 times 8. And you would get 6.12. So that would be my height at that point. And then my area in this case would be base of 10 times height of 6.12. So it would be 61.2 units squared. Again, I'm not trying to scare you or be tough. I'm trying to prepare you. So maybe we should write this down. Yes, sir. No, it would not be 50 times 8, sir. No. It would be the sine of 50 times 8. If it would be 50 times 8, I would have taught you 50 times 8. But thank you for asking. Yes, sir. No worries. So please be aware of the fact that you have to review your SOHCAHTOA and your special right triangles. Please, I am imploring you. Okay, so let us continue here. Example 4. Find the area of trapezoid WXYZ. Tomorrow I'm going to teach you the formula for trapezoid. Okay, it's very simple. It's base 1 plus base 2 times height divided by 2. However, in this example, we're going to show you how that is derived. Okay, how that formula is derived. So in this particular case, the first thing I want to realize is that I'm going to have to drop an altitude. Okay? I'm going to have to drop an altitude. This red altitude over here. When I drop that altitude, look at what happens. If from this point to this point is 18, that means from this point to this point is also 18. Okay? However, I was given a 15 hypotenuse and a 12 height. To me, that reminds me of a 3, 4, 5 triangle times 3. So that's a 3, 4, 5 triangle times 3. That means that AZ is 9. Over here on the other side, we'll do it on blue. Okay? I was given a 13 and only a 13. Okay? I was given a 13 and only a 13. However, since this is a rectangle and this height is 12, isn't this a 12 as well? So then that means that this is a 5, 12, 13 triangle. Again, now we're using Pythagorean triples. As you can see, very simple formulas in this chapter, a lot of backup work. A lot of work that we've already learned. So please be careful of that. So let's first find the area of triangle WBX, which I missed a B here. This should be this little point here. I'm going to call that a B. And that's base times height divided by 2, so 5 times 12 is 60 divided by 2 is 30 units squared. Then let's go ahead and find the area of the rectangle. And the area of the rectangle is 18 times 12, which is 216 units squared. Then I'm going to find the area of my other triangle, YAZ, which is base times height divided by 2. So that is 9 times 12, which is 108, divided by 2 is 54. then I want to find the whole entire area. So I simply and literally add it all together. The sum of the three areas is 300, which is the area of the trapezoid. A trapezoid, if you guys remember when we learned about trapezoids, is simply a rectangle and two triangles attached to it. That's all it is. So even if we were using the regular formula for finding the area of a trapezoid, I would still have to find this 9 and this 5 using special right triangles with the information that I was given. Does that make sense, gentlemen? Are there any questions on that, gentlemen? Promise? All right. And I think we are golden. And yes, we are. I hope you learned a lot. Thank you very much and have a wonderful day. Bye-bye.